Okay, so continuing on, canceling out what we have left, we have x squared plus 8x plus, well, this negative 4i squared, that's going to end up becoming a positive 4, so that's going to end up being plus 20. Okay. So that's the quadratic part from multiplying our two complex numbers together. But we also have a x minus 2, so we need to go ahead and multiply that out. So x times x gives us x cubed plus 8x squared plus 20x. Multiplying the negative 2, we get negative 2x squared minus 16x minus 40. All right, combining like terms, x cubed. That's going to give us 6x squared and 20x minus 16x gives us 4x and then minus 40. Okay. All right, and there's our cubic polynomial. Okay. All right, so then we have left, or sorry, our other way of finding this quadratic is if we had used the formula x squared minus the sum of roots x plus the product of roots. Okay. All right, well, sum of roots. We're just looking at the two complex roots. So our sum of roots, we're ignoring the x minus 2 or the root of 2 when we're talking about sum of roots. We're just putting together the quadratic using our complex roots. So the sum of our complex roots, well, that would be 4 minus 2i plus 4 plus 2i. Actually, that should be negative. Yep, negative 4s. Okay. The 2i's are going to cancel out. We're going to end up with a sum of roots of negative 8. And then a product of roots negative 4 minus 2i times negative 4 plus 2i. Negative 4 times negative 4 is 16. The middle terms are going to cancel out the i's and are going to ultimately cancel out, so we only need to multiply the outer terms, the negative 2i and the positive 2i, which is going to give us a negative 4i squared, which is going to become a positive 4, because I squared is negative 1, which means our product of roots is 20. Substituting that in, we get x squared minus negative 8, that's going to give us 8x plus 20. It's a little bit faster, less chance for error than multiplying it out, but either way works. We'd still have to multiply that times x minus 2. Okay. Moving on to question number 21. So just to specify, let's go put our polynomial here. That was x cubed It's 8x. Oops. X cubed plus 6x squared plus 4x minus 40. Okay. Question number 21. How many real and complex roots does this fifth degree function have? Right now I count 1 real root, 2 real roots, and 3 real roots. That leaves 2 complex roots, which makes sense because they would come in twos. Is it possible that we could have a triple root somewhere? Doesn't look like it because at no point, at no point do we have a sort of bend or kink as we go through. These look like they go straight through the x-axis, so I would consider those just single real roots instead of a triple real root. Okay. All right, so that's going to be our best answer. The extra credit. Cubic function with the integer coefficients has no quadratic term. If one root is 2 plus I radical 5, find the other 2 roots. So I'm going to need a little bit more room for this. Okay. We have we have 3 roots because it's a cubic polynomial, so we'll have 2 plus I radical 5, and we'll have 2 minus I radical 5, and we have a third root, which we do not know. The sum of these roots are going to equal 0 because we have no quadratic term. So the sum of roots equals your second term over your first term. So this would be 0 over whatever our first coefficient would be, okay, which is still 0. So our sum of roots has got to equal 0. We'd get then that 4, the i's are going to cancel out, plus r equals 0. So r is going to equal -4. So one of our factors is x plus 4. And we need to find the remaining ones. Well, we could do it the long way. X minus 2 plus I radical 5 times x plus 2 minus I radical 5. That's a lot of multiplication. I'm going to take a shortcut. I'm going to use our x squared minus sum of roots times x plus our product of roots. Well, our sum of roots, and when I say sum of roots, we're just looking at the quadratic term here that's formed by these two. So we're just going to add those two together, and when we do that, we're just looking at two plus I radical 5 plus 2 minus I radical 5. The I radicals cancel out and we're left with just 4. So our sum of roots is 4. And then our product of roots, if we multiplied those together, we'll do next in the next video because I'm going to run out of time.